This lesson is on dependent events and how to calculate the probability of dependent events. I'm going to put a link up here for my lesson on independent events if you're interested in that too. All right, so what are dependent events? When one event, so one thing that you do impacts the outcome of another, we call those dependent events. So if the first thing you do has an effect on the second thing you're doing, then those events are called dependent. So let's look at some examples here. So read each situation below and determine if it's an independent or a dependent event. So the first one says flipping two coins results in one landing on heads and one landing on tails. So did the flipping of the first coin have any effect on the flipping of the second coin? The answer is no. Whether you get heads or tails on the first coin has no impact on the second coin. So those are called independent events. They do not affect each other. So independent. The captain of the football team is selected, and then the co-captain is selected. So did who was selected for the captain affect who could be selected for the co-captain? And the answer is yes, because if you're selected for the captain, now that person is not available to be chosen as the co-captain. So the first pick affects the second pick. So let's say you were in favor of John being the co-captain, but he was picked as the captain. Well, now you can't pick John as the co-captain anymore. So this is an example of dependent events. The one affects the other one. You draw a joker from a deck of cards, and then you draw an ace. All right, so if you pull a card from the deck, does that affect how many cards are left in the deck? That's the question that you're asking yourself here. And so the answer is yes. So since you took a card out of the deck, now there's less cards in the deck for you to choose from when you draw your ace. So that's dependent. One of the big tests for dependent versus independent is whether or not you replace what you took the first time. So if you went back and watched my lesson on independent, you'll notice every time you pick something, you put it back in before you draw again. So if you were to draw a joker and then put it back in the deck of cards before you drew another card, then that would be independent. But since you kept this card out, now there's less cards in the deck, so that's going to affect your probability of drawing an ace. You draw a queen from a deck of cards, replace it, and then draw a 10. So the fact that you replaced it makes that independent because all the cards are back. All the cards are back in the deck because you stuck the queen back in there. And then the last example here, a coin is flipped and a number cube is rolled. So is what you get on the coin, whether it's heads or tails, going to affect what you get on the number cube? And the answer is no. So these are independent. So if the first one doesn't affect the second one, then they're independent. If it does, then they're dependent. So let's see how we can use this. So use your understanding of independent, dependent events to answer the questions. So Neil goes to the shop, he selects a treat for his dog. He chooses one and then chooses another. What is the probability that Neil selects a bone and then a ball? I feel like I missed something back on the last slide. I think there was more here. Sorry. Let's go down here. So if the two things don't affect each other, that's independent probability. And so the way you calculate probabilities, you just take the probability of A times the probability of B. If the two things do affect each other, so if A affects B, then you're going to take the probability of A and you're going to multiply that times the probability, I didn't mean to, of B have to take into account how A affected B. And that'll become more clear when you see the examples. All right? So let's go back to my example here. So Neil goes to the pet shop and selects a treat for his dog. He chooses one and then chooses another. What is the probability that Neil selects a bone and then a ball? Okay, so the first probability is, what's the probability he selects a bone? Okay, well there's 3 bones and there's 6 items here to choose from. So the probability of a bone is 3/6, which simplifies to 1/2. Now, again, like I said, one of the key things is, did you replace what you took out the first time before you do the second thing here? And it didn't say that we put the bone back in there. So now there's no longer 6 items to choose from. There's only 5 items because we picked a bone and we didn't put it back in there. So now when I go to calculate the probability of picking a ball, it's not out of 6 items, it's out of 5 items. So now for a ball, there's 2 balls, and there's only 5 items to choose from. So now I just take those 2 probabilities, multiply them together. 1 times 2 is 2, and 2 times 5 is 10. And then we can simplify that to 1/5. And you could have simplified right here, the 2 and the 2, you could have cross-simplified to 1 and 1 instead of simplifying it to the end. So again, the key thing is I didn't put the bone back. So the first time I drew, there were 6 items. The second time I drew, there were only 5 items to choose from. So Mackenzie chooses one candle and then chooses another candle. So she didn't put the first one back. What is the probability that Mackenzie selects a polka dot candle both times? So the first time, the probability of polka dot is 2 out of 5. There's 5 candles and 2 of them are polka dot. So 2 out of 5. Well, now the second time, there's only 1 polka dot candle, and there's only 4 candles to choose from because we already took one out. So the second probability for choosing a polka dot is 1/4. Again, you can multiply straight across and then simplify. Right here, the 2 and the 4 can be simplified to 1 and 2. And now when I multiply straight across, I get 1 times 1 is 1, and 5 times 2 is 10. So the reason these are dependent is because what I did the first time affected the probability of the second event because I didn't put something back. All right, so Mrs. Moore is doing laundry and has various pieces of clothing in her laundry basket. What is the probability of selecting a top and then selecting a bottom? So after she selects a top, there's going to be less things to choose from, right? Because we're not replacing. If we were replacing, then these would be independent. But since I'm taking something out and then not putting it back in, these are dependent probabilities. So the probability of selecting a top, get this to cooperate, the probability of selecting a top, let's see, first of all, let's see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 items altogether. I don't know why. I have a hard time. It doesn't usually work out well for me. So what is the probability of selecting a top? Well, there's only one top, this shirt here, out of 16. So the probability of a top is 1/16. Now, what's the probability of next selecting a bottom? Well, remember, there's no longer 16 items. Now there's only 15 because I took a top out. So however many bottoms there are, it's going to be out of 15. And so for bottoms, I have 1, 2, 3, 4, 5. So 5/15. I'm writing this over here because I know I can simplify that to 1/3. So I'm going to do 1/16 times 1/3, multiply straight across, and get 1/48. probability of selecting a striped sock, replacing it, so now we're talking about independent events, and then selecting a striped sock. Okay, so probability of selecting a striped sock is 1, 2, 3, 4, 5 out of 16. I stick it back in, and so now I'm looking at the probability of getting out another striped sock, and so that's also 5/16. I multiply straight across, and I get 25 over 196. So that's an example of independent events because I replaced it. All right. What is the probability of selecting a towel, replacing it? So I'm replacing it. So these are independent, and then selecting another towel. Well, let's look up here. There was only one towel out of the 16. So we're looking at 1/16 times 1/16 because I replaced it. So I multiply straight across. Let me check 16 times 16. Is that really 196? Doing that in my head, but no, I'm not so sure. No, it's 256. So let me go back up here. Sorry about that. 256 for 16 times 16. And so what we're looking at here is 1 over 256. Number 11, what is the probability of selecting a skirt and a top, one choice after another? There's no replacement here, so we're talking about dependent probabilities. So selecting a skirt, let's see how many skirts there are. 1, 2, there's 2 out of 16. So for a skirt, I'm going to write it over here because I know I can simplify it. That's 1/8. And then a top, I think there's only one top, but let's check. Sorry, I'm trying to find my pointer. It disappeared on me. Yep, there's only the one shirt here, so there's only one top. But it's not 1 out of 16, it's 1 out of 50 because I took the skirt out and I didn't put it back in. Actually, I took two, let me correct that, I'm wrong. I took out, wait, what is probability, sorry, what is the probability of selecting a skirt? So I took one skirt out. So now there's only 15 items left, and one of those is a shirt. So we're looking at 1/16 times, turn this off, I'm right at the same, it's 1/15. So 1 times 1 is 1, 16 times 15, all right, I'll quit trying to do this in my head, is 240. All right. So, I'm looking at my answer and it says I did something wrong. What did I do wrong? I'm going to go check. Hold on. All right, so I just realized what I did wrong. 2/16 simplified to 1/8, but I put 1/16 here. So it's not 1/16, it's 1/8. I knew something was wrong. So 8 times 15 is 120. So it's 120. I'm not doing very well today. Sorry about that. All right, so let's look at this last one. What is the probability of selecting a matching pair of solid socks, one choice after another? So a solid sock and then a solid sock. And I'm not replacing, so these are dependent. All right, so let's see, what's the probability of a solid sock? There's 2 solid socks, no, 4 solid socks out of 16. 4 solid socks out of 16. So write this over here because I know I can simplify that to 1/4. And then the next time, there are only 3 solid socks left. Okay, so there's only 3 because I took one the first time. There's 3 solid socks, and there's only 15 items to choose from. And 3 over 15 is 1/5. So let me go over this one more time because I didn't show you one like this before. There are 4 solid socks, so the the probability of drawing a solid sock is 4/16. Now the second time now, I've taken a solid sock out the first time, so now there's only 3 solid socks. And there's only 15 things to choose from because I took a sock out already. So that's why this one is 3/15. So those simplify to 1/4 and 1/5. So we're going to multiply 1/4 times 1/5, and that gives us 1/20. All right, so I hope that was helpful to you, especially in understanding the difference between a dependent and an independent event. If that was helpful to you, give it a like and a subscribe, and please feel free to leave me a comment if you have any. Until next time.